Every time you take a step with a smartwatch, upload a video, or click a link, you are generating information. We are constantly surrounded by a massive, invisible ocean of data points. In its rawest form, data is simply a record of events. Think of a local school cricket match where someone writes down an exhaustive list of every single run scored, every ball bowled, and every catch dropped. Much of what we produce is unstructured data. These are complex files that don't follow a rigid format, things like photos, audio recordings, or social media posts. They contain rich details, but they are messy and difficult to sort. This graphic breaks down the alternative. On the left side of the panel, we have structured data. This information is neatly organized into easily searchable rows and columns, exactly like a spreadsheet of student marks. We produce mountains of both types every single day. But here's the problem. A raw list of numbers or a folder full of unorganized files is completely useless without a reliable way to interpret it. Modern computers are incredibly good at handling this volume. They can perfectly store, arrange, and retrieve millions of data points across massive structured databases without breaking a sweat. Human biology, however, is not built for this. If you stare at a spreadsheet containing a million cells of raw numbers, your brain cannot instantly process it or find any inherent meaning. So how do we translate that perfectly stored digital chaos into a format that the human mind can actually comprehend? To make real-world decisions based on all this collected information, we have to build a cognitive bridge between the computer's memory and our own understanding. Before any translation can happen, the raw material has to be prepared. We clean the data by removing errors, deleting duplicates, and filling in missing values, so we are working with a clean slate. Once the data is organized, we bring in our ultimate translation tool, data visualization. Our brains evolved to recognize visual patterns in the physical world. Because of this, we can process shapes, colors, and spatial relationships in a fraction of a second, much faster than we can read individual text or calculate math. Visualizing data fulfills a biological requirement for human comprehension, allowing us to see meaning where raw numbers offer none. Different cognitive problems require different visual tools. Bar charts, for example, are the ideal format when your brain needs to rapidly compare the specific quantities of different categories side by side. This pie chart shows how different daily activities divide up a person's time. We use this format when the goal is to understand how individual parts combine to make up a complete whole. Meanwhile, this line graph visually plots how a specific variable changes over a continuous period of time. You instantly register the upward trend from January to March. Now, let's return to that chaotic list of cricket match data. Reading down an endless column of runs and dropped catches completely hides how the players actually performed on the field. Watch what happens when that raw data morphs into a line graph plotting runs over the final overs. The visual exposes a sudden spike, instantly pointing out the most effective bowler late in the match. By selecting the correct visualization tool, the digital noise drops away, revealing the hidden, actionable story inside the numbers. Creating a highly readable chart is only the beginning of data analysis, not the end. There is a common analytical trap, assuming that just because a computer gives you a crisp graph with highly detailed numbers, those numbers represent the absolute truth. The dartboard on the left represents precision. The darts are grouped tightly, but completely miss the target. Pan right and you see accuracy, measurements close to their true value. But only in the center board do we find valid data, hitting the bullseye. Your chart might plot a trend line out to 5 decimal places, but if the underlying data wasn't accurate to begin with, your visual is effectively just telling a highly detailed lie. To safely make decisions based on numbers, you have to ensure you are working with valid data, measurements that possess both high accuracy and tight precision. This is the true role of a data analyst. They observe the real world, organize the resulting chaos, and expose hidden patterns. From there, they have to apply critical thinking. They must evaluate the source material to determine if those visually exposed patterns represent an actual truth or just a precise error. Mastering these visual tools provides the bridge necessary to turn overwhelming digital noise into actionable clarity.